for about. Yeah. Okay. Yes.
You're live.
We are live. Okay. Hello, everyone. My name is Bram. I have Shuyao with me. We're both data engineers at DataRoots. We'll be talking about metadata hubs today. Before we get started, maybe first make some advertisement for our upcoming RootsConf. It will happen on the 29th of April, and we will have some talks for you, 4 in total. Stay tuned. We'll announce them via Meetup. So voila. All right, and we can get started. Let's include the slides. There we go. So we'll be talking about metadata hubs today. Despite our title, metadata hubs are not a silver bullet that that solve all of your data governance problems, but it can definitely help you to govern your data. So voila, let's dive right in. So maybe first, what are metadata hubs? Often companies ask themselves questions like, where is a certain data set located? What does that data look like? Do I have access to it? Who owns it? Is there any sensitive data that we have to handle with special care? What feature is in a certain table, or where can I find certain information? And of course, also, where is data coming from? Where is it going to? How is it consumed? Which queries are run on it? And so on and so on. All right. So, and all these questions you can answer with metadata, which is basically data about your data. And this metadata is stored in metadata hubs. Metadata hubs can help you to discover your data, to explore it, to manage it, to keep track of changes, for example. All that with the data that you have, for example, in your organization. They can also help you to set procedures and rules about accessing your data, about reading it, about how to process it. Here's an example in Data Hub. Data Hub is a tool used or developed by LinkedIn, rather. But there should be a GIF that's not playing. Can we do something about that or not?
I don't think so. Maybe if you probably share the top. Maybe if you share your screen.
Yes, let's maybe go out of it for a second. We'll be right back. Share slides from my computer.
If you share, I'm going to share screen instead of share slides.
Yeah, okay. Share screen. We'll share a tab. This one, namely, Okay. There we go. Is it visible? Yeah, you have to change the stream, right? Yes, all right. Sorry about that. So here is an example in Data Hub developed by LinkedIn. So you can explore your data sets. You can select one, go through your search results, and then have a look at who the owner is, what the schema looks like, and so on and so on. And then finally, metadata hubs can also help you to keep track of where your data is coming from, where it's going to. So basically, it's data lineage. So which applications are producing a certain data set, which ones are consuming it. Here you can see in Marquez, another tool, an example of applications producing data sets, and these data sets are then again consumed by other applications. What we're going to do now is have a look at multiple architectures. There are 3 in total, and then apply them to some tools that are out there. We've not invented this ourselves, of course. There's an excellent blog post written by LinkedIn about metadata hubs. They really walk you through their own journey, so it's very interesting. They go from one architecture to the next and tell you why one is working for them and another isn't. For example, what the limitations are and so on. So it's really a good read. The first architecture is a very simple one. It's just a monolithic application with a metadata store with the search index. And what you're going to do is batch load metadata that results from crawling your database, from your logs. It's really as simple as that. An example is Amundsen. We have a Through the Tool session about that. That's very interesting to have a look at if you want to. It's such a simple architecture. We can be very brief about it. It's easy, so it's easy to implement and maintain, and that makes it very good for small teams that just need a catalog. But of course, there's the batch loading that raises questions like when should you do it? How often should you do it? It can result in issues. Result in issues with data consistency, with the up-to-dateness of your metadata, and there are no programmatic use cases, so that's also a disadvantage. And this last part is solved by the second architecture, which includes a REST API, and instead of having the monolithic application, there will be microservices. There's the metadata service that you can see that handles all the API requests, and it interacts with your front end and with your metadata store. An example or multiple examples of this architecture are listed here. There's Elation, there's Calibra, which is a commercial tool. There's also Marquez. It's an open source tool that we've had a look at. So let's apply the architecture to it first. There's the API, there's the metadata database. And in the case of Marquez, there are 3 chunks belonging to the API. There's the lineage, there's the core, and there's the search part. And then there's the metadata service that handles all these API calls and interacts with the metadata database and gives responses where necessary. And then there's on top of the API, so there's the integrations part used to ingest your metadata, and it lies on top of the lineage and the core in the API. And there's, of course, the user interface that lies on top of a part with the search block and, again, the core. Let's then maybe have a look at the user interface. So there are datasets and jobs that you can have a look at, jobs to ingest your metadata, and then the datasets themselves. And on the right, you can select the namespace, which can help you to subdivide your datasets and your sources into multiple groups. Let's then have a look at the API. This is in Python. You can just install a module and then set your connection details. And then afterwards, you can define, for example, a namespace or a source with the integrations that are there, and so on and so on. Talking about those integrators, you can use Apache Airflow, you can use Apache Spark, and there is dbt. The people that are behind Marquez are also behind the Open Lineage framework, which is a framework that defines how Lineage APIs should be implemented, what they should look like. And so the Lineage API for Marquez is built on top of that framework, or at least with that framework in mind. Here's an example of Marquez that's being used with Airflow. You can define your connection details once again, a namespace, and if you submit a job, so to do that, you can just define a directed acyclic graph, a DAG, like you always do in Airflow. And once you submit that, it will show you that there are some post requests made to your metadata hub. And that makes sense because, of course, you have submitted or you have created jobs in your metadata hub. If we then have a look at the user interface, so if we select the root conf, in this case, namespace, there won't be any data sets yet, but there are the jobs that we've defined. After having a look at Marquez, we can conclude that it's pretty simple to use still. It has nice integrations with Airflow, with dbt, with Spark. There is a way to version jobs and datasets, which is a very nice feature. And it's really designed for developers. So it allows for us as developers to easily interact with it, to write programs to interact with it. The user interface is, in terms of features, not very extensive. So people with a less technical background might not find everything they would want or need in there. You can consider it opinionated to some extent due to the Open Lineage framework. That doesn't have to be a problem, but it's something to keep in mind. And Marquez is still pretty early stage. So not everything might work as expected, or not yet at least. All right, then having a look at the architecture in general, it's still a pretty simple architecture, still pretty easy to implement and maintain. You can use APIs and you can write code to interact with it. And all that really makes you the owner of your own metadata. What you can't do yet in this architecture is subscribe to changes. So you still have to schedule the update of your metadata. It's not that when something changes, that's automatically captured. And finally, it is a centralized architecture. So scaling might not always go perfect, or might not be easy. Voila. Then we are at the third architecture. Let's maybe have a look while Xiao shares her screen, if there are any questions, but not yet, so it seems. I'll let you share your screen. That might be easy.
Okay.
So feel free to ask any questions if you have them.
The slide is loading.
Yep.
Oh, can you close your slides that you're sharing?
Yeah, sure.
It seems I cannot share my screen.
How many to close this?
Not anymore?
No.
That's it? And
Okay, from this slides, we are going to talk about the type 3 architecture. Sorry, I was muted. So I was talking this type 3 architecture, and this highlight of this architecture is the streaming framework. So any changes?
We don't have sound. 1 second. I think we have sound now.
try again.
Yeah.
Can you hear me now?
Yeah, but you should
Okay.
not unmute yourself.
Do I mute or unmute?
You don't do it. Just don't press anything.
Okay,
Should be fine with this.
so it's okay now.
I hope so. Yeah.
Okay, thank you. Sorry for the inconvenience. I was talking about the type 3 architecture, which has a biggest advantage, streaming framework. So any changes made on the metadata source will generate a change log, and the metadata hub will be able to process this change log and update its metadata objects accordingly, including the search index, the metadata objects, and also will send notifications to these external services or applications built on top of that. A typical example of this architecture is the Apache Atlas. As you could see, this is the architecture of Atlas. It supports various metadata sources like a Hive HBase. And when ingesting this information, you can either use Kafka Messaging method or using the REST API. This process will be done by using the ingest or export core component in Apache Atlas. So it's used to process the change log to deal with the change events. And all this metadata information will be stored by using Genus Graph, in which the metadata objects stored in HBase and the search index stored in the Solr. There are also other two important core components, type system and the graph engine. We will cover them in the coming slides. Finally, Atlas also has supports external services. It also has web applications for end users to interact with the metadata objects very intuitively. So the first core component we are going to talk about is the type system in Atlas. Speaking of type, you can refer this as a class in an object-oriented programming language. So as you can see, it's an example showing all the types related to HBase. So this is a tree structure, so you can easily find the inheritance relationship between different types. For example, this HBase table type, it inherits from the dataset. So it has all attributes of dataset. If you click on this type itself, you will also find other detailed information like who created this type and also like what's the last update time. Then another core component resides in the type system is entity. As you can see, entity is a specific instance of type. So this sales fact table, it belongs to the table type. You can also find relationships between different entities, like these 4 columns. They belong to this table, but each column, they belong to the column type. This relationship is enabled by the graph engine, as we talked before. So it shows the rich relationship between different entities for users to find their relationship. Then when ingesting data, the first way you can use the REST API is pretty easy to find the detailed documentation in their official website. And what better is they also provide an interactive interface for you to explore how this API could be used. So it's very friendly for developers. And another way is by using the Kafka messaging framework. So there is a very special type called Kafka topic. And in this type, there are 2 different entities, Atlas hook and Atlas entities. So any change events will be sent to this Atlas hook. So after Atlas got this notification, it will update its metadata objects, also send this notification to Atlas entities. So in this way, it achieved a better scalability. For example, if you would like to build your service on top of this Atlas, you can just subscribe to these 2 entities. Then you can achieve your metadata consistency. After talking about the core components, we show some features of Atlas. This is admin UI. So here you can find the audit log, like who created what, and you can also find the statistics, like how many notifications you received from this Kafka topic. So it's very intuitive to use to manage and update your metadata objects. Then another very important feature provided by Atlas is the business taxonomy. As you can see on the top left, there is a tab called glossary. So what does this mean? Imagine you're a data analyst and you would like to find something related to your customer. But as you didn't create the table, you didn't define the columns, you might not know what specifically you are looking for. So how can we solve by using Atlas? For example, under the glossary, I defined this category called users, and under which there is a customer subtype and a users type. Then, as you can see here, there are 2 entities, the dimensions table and also the column customer ID. This column, I assign these entities to this category. So when you type the keyword customer, you will find everything related to this customer, everything related to this keyword. So it's very useful for business people who didn't know much about the naming conventions of the tables or columns. Then another functionality is the Ranger tag-based policies. So in case you didn't hear the Ranger before, Apache Ranger is a security framework for users to manage the access and also to, for example, mask the sensitive data if needed. So on the also on the top left, there is a classification tab. And here it's a list of all the tags already predefined. We take this PII or personal identified information as an example. As you can see, these entities, they all have this tag PII. As you can see, they're all sensitive information. So you can easily, after you have attached the PII tag to these entities, you can easily go to Ranger to manage like who could access this tag or even mask some information if needed. So Ranger, it's a consumer of these metadata objects. So it will notify by the Kafka topic if there are anything changes made on the classifications. I also would like to mention here is Atlas supports the classification propagation. What does it mean? So if you have an entity tagged with this classification, or other entities related to it will also have the same tags. So it saves a lot of work when you're managing this entities security. Then we go to the most commonly used for feature data search. So Atlas supports you search the entities by type, by glossary, by classification. You can also filter your result by like who owns this table or what the table name is like. If you prefer to use some SQL-like query, you can also easily do by switch this button to advanced and type your query here. Then the final functionality about the data lineage, you can easily find it when you click into the entity itself. If you click on the load process, you will also find the source and what the merge or joining conditions here. So here I only show this it's table level lineage, but after Atlas version 0.8, it also supports column level lineage. So you can find what this column is calculated by using other columns. And again, this relationship is enabled by the graph engine of Atlas. So after this overview of Atlas, we conclude some good points and some points need to be improved. First, Atlas it supports rich features. So almost everything you could say in the when you dealing with your metadata, and the web UI is intuitive for user. It's easy to use. Also, the documentation is very detailed for developers. However, you will always need to balance the complexity, not balance, but like the complexity, the terminologies, it's very, not very, but a bit hard to understand at the beginning. So you might get a stiff learning curve. And also this Atlas framework, it's tightly coupled with Hadoop ecosystem. So as you could see before, it has some predefined models or type systems for this metadata services. However, if you would like to build your own metadata source, it will be a lot of code work. So by showing Atlas, we conclude some pros and cons of Type 3 architecture. First, it's a highly distributed, it's scalable, so you won't be blocked by a central team on managing these things. And also because of the use of streaming framework, you get almost a real-time metadata consistency. And then you get the trade-off between complexity versus functionality. And because the complex use, it won't fit all the use cases. For example, if you just like a startup company or you don't have enough human resources on managing the metadata, it will be a high workload for your team to use the Apache Atlas framework. So far, if there are any questions. Yes.
Let's have a look. I have one. No questions?
I don't think you have a question yet.
Okay.
Okay, if no more questions, no, maybe we can continue on the next.
There we go.
Yes, so in this presentation, we have shown how Metadata Hub could be used to provide the metadata related functionalities. First, it supports the data catalog, so you can manage your data like how you manage your physical assets in your company. It also could be used for data lineage, so you can track how your data go from the very beginning to the consumer, like how you track and package ordered online. It also supports the data security, so you can manage or define some rule policy to manage your data to comply with some regulations. And in this industry, we have found many people have realized the metadata is really the key to the company, and there have been different architectures, different tools developed for this purpose. However, we would like to say that we did in this presentation, we didn't say type 2 architecture is better than type 1 and type 3 is better than type 2. It really depends on your needs. So we hope this presentation can provide you some inspirations on how to choose the best tool suitable for your case. And if you are interested, we also provide some resources for you to have a deep look. First, this is the Data Hub, the blog post, like Baham mentioned, we based on our 3 architectures on this article. And if you are interested in data governance, we have an introduction on this data governance a couple of weeks ago, presented by our colleagues. And finally, we also have an article on our official website. It concludes all these tools, the architectures we just presented. And finally, there are also a very interesting topic for you to look. It's called metadata management. So it has a great cross with the data governance. So if you are interested, have a look of that. Finally, we would like to mention Fauzi Paza also made a great contribution on this evaluation. So we really would like to thank his contribution. And if there are any questions, no more, we thank you for your attention.
There was one, I think. Yes. I haven't encountered any organizations that are using Ranger. So I wouldn't know myself. For the clients that I've worked for, at least, I haven't encountered it.
Yes, but I noticed like a client I'm working on, they use this Ranger framework to manage their access. Like each user is assigned to a business role, and they use this framework to manage what kind of service this business role could be accessed.
Okay. Voila. I think there are no more questions. Then we can conclude it here. Thanks a lot for your attention. I hope you enjoyed it despite the technical issues that we had. And stay tuned for our RootsConf, I'd say. See you.